Hello, it's your favorite chemistry tutor, Famjo. Now, let's take a look at this topic, fatty acid. Now, today we are going to be looking at Iupac of fatty acid. Iupac of fatty acid. Now, what is fatty acid? Fatty acid is a long chain carboxylic acid. Fatty acid is a long chain carboxylic acid. Is a long chain what? Carboxylic acid. Now, you all know that the functional group of carboxylic acid is COOH. So, RCOOH. So, fatty acid is a carboxylic acid. But the unique thing about fatty acid is that it has a long chain carboxylic acid. It has a long chain carboxylic acid. You can see it is long. I have a longer one. So another point you should know about your fatty acid is that your fatty acid can be saturated and your fatty acid can be unsaturated. The first point, fatty acid is a carboxylic acid, but a long chain carboxylic acid. Now, I see your COH. Second thing is that your fatty acid can be saturated without a double bond, unsaturated with double bonds. Is that okay? Now, for example, look at an example I put on the board. This fatty acid, common name of this guy is called linoleic acid. This is a linoleic acid. Now, one thing about this linoleic acid is that you can see it has a double bond. Because it has a double bond, I call it a what? Unsaturated fatty acid. Now, we have a couple of natural unsaturated fatty acids. Is that clear? We also have those ones that are what? Saturated, that do not have a double bond. For example, guys like palmitic. Palmitic is a 16 carbon carboxylic acid. It's an example of fatty acid. It's a 16 carbon without a double bond. Palmitic acid is 16. I think steric is 16 carbon without double bond. Myristic is 14 without double bond. You notice that those guys come without a double bond. So we have fatty acid that is saturated, and we have those that are what? Unsaturated. I think those points are clear. Now, let's look at this example I have on the board. This guy is linoleic acid. Now, for linoleic acid, you can see how beautiful this is. This guy, if you count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This guy has 18 carbon with 2 double bond. 18 carbon with 2 double bond. Now, this is the line formula. Then if you want to write it, you know this is CH3, this is CH2, 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 CH. So this is another way to write it. And for some people, you can write it as more like in shorthand. You can say CH3, then count 1, 2, 3, 4. You can put all of them there and say 1. Then you can say CH2, 1, 2, 3, 4. You can say 4. Then you say this is CH, double bond CH. Then what else do you have there? There's a way we can put it together in such a way that then we have a CH here, we have a CH2 here, we have CH, we have double bond CH. This is 1, 2, 3, 4, 5, 6, 7. We can say CH2, the whole of the CH2 here is 7. Then COOH. I'm just trying to make it smaller so you can see your CH3, CH3, CH2, CH2, CH2. 1, 2, 3, 4. CH2 is 4. Then CH, double bond CH. Can you see that? Then this is CH2. Now this is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, that's 18. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's 18. So you can see them writing it in a very shorthand method just to compress it. So this is still the same thing as this, is the same thing as this. I think that is clear. Now, let's start with how do we name this? How do we name this compound? Very easy. How do we name this compound? Now, to name this compound, we have two systems that we use. We use two systems. Now, naming according to chemists and naming according to nutritionists. We have nutritionists, biochemists, medicine, people in medicine. They have a way to name fatty acid. But as chemists, there's a way we name it. As chemists, we have a way we name it. And chemist is the Iupac, which is the generally accepted way of naming it. Meaning you can see it as omega, but that is not Iupac. So Iupac, generally accepted name is the way the chemists name it. So I'm going to teach you how to name it, then also teach you how to add it in we have it in shorthand method. So let's take a look at this compound, linoleic acid. Linoleic acid. Now let's take a look at this compound. Now, firstly, you want to name according to chemists. When you are naming, you start naming from the carbon of the functional group. Are you with me? This is the carbon of the functional group. So if I'm naming it, I say 1, 2, 3, 4, 5, 6, 7, 8, 9. A double bond is in position number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. According to a chemist, you start naming, put it down. If you are naming according to the chemist, I mean your fatty acid, you name starting with the carbon of the functional group. So I start counting from this carbon. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9. So that is 9. So this is 9. 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. 13, 14, 15, 16, 17, 18. Now we have 18 carbon. Now, according to our root name, you know, if you have 1 carbon, you say met. If you have 2, you say et, pro, boot, pent, x. 10 is deck. 12 is on deck. 11 is do deck. Then 13 tri deck. Is that okay? So when you get to 18, this is 18 carbon. 18 carbon is going to be called what? Oct deck. So octa deck. So we use something like octadeca. So this is 18 carbon. This guy is 18 carbon. 18 carbon. If I count from this, it's giving us 18 carbon with double bond. How many double bond? 2 double bond. Now, another information I want to give you about most natural fatty acid is that their double bonds are always 3 carbon away from each other. For example, this one was in position number 9. 9, 10, 11, 12. The next double bond was in position number 12. So, in most natural occurring unsaturated fatty acid, their double bond are always in position 3 to each other, like 3 carbons away. So you see, this is the first double bond is position number 9. When we are counting from here, 9, 10, 11, 12. So we have 2 double bonds. One is in position number 9 and one is in position number what? 12. If I count it based on the way chemists name what? Name fatty acid. So if I want to name this, I'll say octadeca. I say octadeca. Now, don't forget, where is the octadeca coming from? 18, oct, 18, deca, 10, 18. Octadeca, the whole carbon here is 18. Now, don't forget that they are double bond. How many double bond? 2. So, octadeca, according, don't forget I counted from there. Octadeca 9, 12, dienoic acid. You know that the end name of all carboxylic acid is noic acid, like butanoic acid. But in this case, don't forget that I use the word E, not ordinary noic, dienoic. Why dienoic? Diene, this statement dienoic is coming from the fact that we have what? 2 double bonds. One is in position number 9 and the other one is in position number what? 12. So I name it according to who? I name it according to the chemist. Now, there's a way we can name according to nutritionists, biochemists, in medicine, there's a way we name it. Now, according to the nutritionist, if you are naming, don't forget, this is the generally accepted way, by chemists, by Iupac, By Iupac, this is the accepted way. 9, 12, starting your naming from here. Now, this same compound now, I want to name it according to biochemist, and what according to the nutritionist. Now, to do that, what is the difference between naming according to the chemist or naming according to the nutritionist? According to the nutritionist, we don't start counting from this carbon or the functional group. We start counting from the end. Our end here is the methyl, and this is the methyl. We start counting from the end, which is the methyl. So let me start the counting. So this is 1, this is 2, this is 3, this is 4, this is 5, Abi, this is 6. So one double bond, don't forget, one double bond is in position number 6. One double bond, I'm counting from the back, from the methyl. 1, 2, 3, 4, 5, 6. One double bond is in position number 6. So this case is 6. Let me mark it. One double bond is in position number 6. Position number 6. Then let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Another one is in position number 9. So 6 and 9. One is in 6, one is in 9. If I count from the back. Now, according to the nutritionist, biochemist, and the medicine, we do the counting from the back. But according to the chemist, they do the counting from the front. I mean, from the functional group here. And because they did it from the functional group here, they got 9, 12. This is 9 and this is 12. But if I count from the back, it gives me the first one is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I want to name, according to them, I will say octa, it's still octa, deca, octadeca. Then I say what? 6, comma, next one, counting from the back here, comma 9, dienoic acid. Octadeca is 18. 6 means you are counting from the back. The first double one is in position number 6. The next one is in position number 9. Don't forget. So, meaning that these two Iupac is still referring to this same fatty acid, which is linoleic acid. It has 18 carbon, octadeca. It has 2 double bonds. One is in position number 6, position number 9, or position number 9, number 12. Now, this is written according to the nutritionist. I'm using the word nutritionist. Then this is written according to the chemist. Iupac is International Union of Pure and Applied Chemistry. In chemistry, meaning we use linoleic acid is written as 9,12. That is because we started counting it from this part. I mean from the C, the carboxylic acid. We got 9,12. Position number 9, position number 12. When we started counting from the back, which is according to what you will see according to chemists and biochemists, we got position 6 and position what? 9. That's 1, 2, 3, 4, 5, 6. Now, to avoid any form of confusion, because somebody writes 6,9 and 9,12 is given to you, and you might not know, unless you are familiar with the facts and you know the way linoleic acid looks like. I mean, you know the structure of linoleic acid, you know that it is 9,12, it is written as chem. So there are other ways to ensure that you do not confuse these two together. So we're giving a shorthand method. A shorthand method. Now, this shorthand method, I'm going to teach you how we go about it. But before that, I want to mention something. 1, 2, 3, 4, 5, 6. When you are counting from the back, the first double bond was in position number 6. Because the first double bond is in position number 6, I'm going to make a reference to it when we are dealing with shorthand method. Now, we have 2 shorthand methods, and that is the omega system, and we have the delta. The omega system, and we have the delta. We have the delta system. Now, not to confuse everything together. So we have 2 systems. We have the omega system and we have the delta system. We have the omega system. I hope you put it down, put that one down. Now we have the omega system, we have the delta system, because I'm going to clean up everything. So ensure you are writing, put everything down. Now, omega system, we use omega system, shorthand method, and we use delta system. Now these two can help us, this omega and delta helps us to showcase the position. Tells us that, oh, when you are using omega, it means this. When you are using, now who use omega? Omega is used by nutritionists. So your nutritionist is the one using omega, meaning that anytime you hear omega, you use omega, you see omega fat, omega fat. Use that in medicine, in biochemistry, in that field. But anytime you see delta, delta is used by chemists in Iupac. So why are they necessary? We use them to denote our double bond. We use them to denote our double bond. For example, I wrote this guy according to what? I wrote it according to omega. According to the nutritionist. If I want to denote it, it's shorthand method. So write shorthand. We have shorthand method. For the shorthand method, now this is octa-deca. Don't forget that we wrote this according, we counted from the back. You say 18 to, what's the meaning of 18 to? 18 means all the carbons are 18. 2 means we have two double bonds at different positions. Then you say omega. Now, anytime you use the word omega, you should know that you are counting from the back. So 1, 2, 3, 4, 5, 6. Omega 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So this, immediately anybody write this to you, you understand that if you want to draw this structure, it is an omega. Meaning I'm going to draw it having in mind that whenever a nutritionist want to draw their structure, they start counting from the back, because I saw omega. Omega means I'll start counting from the back. So if I want to draw it, I would have known that after writing my longest 18 carbon chain, then I will know that it has two double bonds. Then this means that one of the double bonds is in position number 6, the other one is in position number 9, if I count from the back. I think that is clear. Now if I want to repeat the same thing in what? We can repeat it also in a delta with this is omega. In a delta, you say 18, let's put it here. 18 to, 18 means 18 carbon, 2 means it has two different double bonds. Now, delta, now, if I'm using delta, 18 to, two double bond is present there. Is that okay? 18 to two double bond is present there. But I'm using a delta system. If I'm using a delta system, who use delta system? Chemist. I'll start counting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 10, 11, 12, 12. So, this way, there won't be confusion, because if I just write octa-deca 6, 9 dianoic acid, if I ask to draw based on this, you might be having a mindset that 6, 9, you might start counting from there. Because nothing is indicating if you have to count from the front or from the back, unless the information says that. But looking at this, let me take a look at this. Immediately you see this is a shorthand method, and immediately you see omega, you know that the 6, 9 is the position of the double bond. 6 means one is the position number 6, then the other one is position number 9. And when I see omega, I count from the back. When I see delta, I count from the front. It's as simple as that. And the funny thing is that this is linoleic acid. This is still linoleic acid. This is still linoleic acid. And this is still linoleic acid. Because if I draw according to this structure, 9, 12, if I count that structure, it will still give me the same thing. So the two of them are the same in nutshell. Not that if you draw this, the structure will be different from this. No. If you draw this, the structure will be the same thing with this, because these two information is talking about linoleic acid. If I draw according to this, counting from the back, and I put 6, 9. If I check it, it wasn't giving 9, 12. I think you understand that. So meaning that this and this is talking about linoleic. This and this is talking about linoleic. It's just that one is delta and one is what? Omega. Omega delta. Please put that down. So if there is no double bond, there are situations where there is no double bond. For example, if you don't have a double bond and you just have something like 18O. The only write 18O is a shorthand method, 18O or 16O. 18O means no double bond. So we don't need delta or omega. This is, I think this is that's steric acid. If you want to name this now, that is octadecanoic acid because it's 18. And why this one is hexadecanoic acid? You can see that there's no double bond. But in the case of all these guys, we have dienoic. Enoic means there's a double bond. I think that is clear. So I can write a shorthand method very well. So another thing I'll quickly teach you is this. Your fatty acid, we have what we call essential fatty acids. Essential fatty acids, according to nutritionists, fatty acids are divided into we have what we call essential fatty acids. These fatty acids are gotten from diets, and nothing our body can synthesize. We get them from diets. So there are two types of the fatty acids, according to nutritionists in medicine. In biochemistry, we have two types. We have the essential one which are omega-3, and we have the essential one which are the omega-6. And I want to teach you how to locate them. Omega-3, omega-6. How do we go about that? Very simple. Sorry, I will need to clean up this. I think you have put that down. So we have omega-3, omega-6, omega blah blah. So we have omega-3 and omega-6. So write it down. Omega-3 and omega-6, they are the two essential fatty acids. Omega-3 and omega-6. Now, how do you know your fatty acid is omega-3 or omega-6? Very simple. We gave them name based on this. The omega-3 and omega-6, we gave them name based on the fact that when you start counting from the back, the position of the first double bond is the name you call it. So if I start counting from the back, you see everybody 1, 2, 3, 4, 5, 6. My first double bond is in position number 6. So I can say linoleic acid is an omega-6. Or somebody wrote this for me, 18 to omega-6,9. I know this is what? A fatty acid. A fatty acid that is written according to omega, meaning that when I'm counting, I should count from the back. My first double bond is in position number 6, and the second one is in position number what? 9. So if somebody asks me what type of fatty acid is this? This is what? Omega-6 fatty acid. How do I know that? It is written according to omega. This is the first double bond. If you are counting from the back, this is the back. 1, 2, 3, 4, 5, 6. Omega-6. If I count from the back and the first double bond is in position number 3, we call it omega-3. I think that is clear. Count from the back, the first double bond is in position number 6, omega-6. Count from the back, the first double bond is in omega, if it's in position number 3, we call it omega-3. I think that is clear. Thank you. So the essential fatty acid can be omega-3 and omega-6. But in the case of linoleic acid, it is omega-6. And if somebody asks you, how do you know it is omega-6? When we started counting from the back, our first double bond is in position number 6. I think that is clear. And that is why somebody can write this for you. It's telling you that it's omega-6. Now, thank you. Another thing I want you to remember, I told you that most natural unsaturated fatty acids, what did I say? How many double bond is here? 2. And I said the first one was in position number 6. I said they are always in position 3 away from each other. I think that is clear. So if this is 6, the next one is what? 9. Is that clear? So if somebody write this for you, 2 omega-6. Now, first, you notice that the person indicated that 18 carbon, there's a 2 double bond. But it was telling us omega-6 is just mentioning the first double bond. Omega-6. And it's that we're expecting to put the second position, but we should know because we already know that if the first one is 3, And how many double bond are we having? Two. And I said they are always in the position of what? Three to each other. If this is six, the next one should be what? Nine. So if somebody writes this thing this way for you, it's still correct. This is still this. Because he believes that the next position should be three to it. Thank you. I think that is clear. Another thing is that you can see it written this way. Yes, let me pay attention to that. This whole thing like this omega, you can see it written in another way. You see some people saying 18 to, instead of saying omega 6, you can see 6 here, omega 6 9. They just say n minus whatsoever the first double bond. What's the first double bond there? It's not the first double bond here is position number 6, just say minus 6. So these two is still acceptable. So if somebody writes 18 to n minus 6, I should repeat this statement back here. I'm just saying 18 to Abi omega, what's it? 6. Then I know that their double bond is 2. The next one should work like that. 9. Maybe I should go over it again so that some people can understand that clearly. I'm telling you that this guy is 18 to this guy that we have here, we can write it as it's still omega 18 to, then you say, instead of saying omega 6 9, you can say, what's the first thing here? 6. Let's say n minus 6. I'm not saying, let's imagine that what they gave you was 18 to n minus 6. It's still omega. It's still telling you about omega. This is omega 6. Maybe you see that you know it's omega 6. I want to write it back. Just say 18 to omega. Are you following me? When you say what was it? 6. You know that this is 2 double bond. If the first one is in position number 6, they are 3 away from the next one, so 9. So this is writing in what form? Omega. Now, how can I? The next thing is I want to write according to delta. You know, I told you that delta means you're counting from the front. Now, but what I want to do is this. I want to teach you how to convert this information. I mean, if the omega form is 18 to omega 6 9 or 18 to n minus 6, you want to convert this statement straight, because I can draw this thing out, and after drawing it, I can then get my delta. But if you don't want to do that, you want to convert this information straight to the delta form. I mean, what is the delta form of this fatty acid? It's very simple. You just say 18 to delta. I want to transfer this omega form of our linoleic acid. I want to turn it straight to the delta form, from omega to delta. See what I will do. I won't draw this thing, and I will get the delta form. So you don't need to be drawing every time before you get this. So if I have this, I can change it straight to this. And how do I do that? Very simple. Told you. What you do is this. First, what we have here, we have 18. And what we have, the first one here is 6. Or you say 18, 6. This is omega 6. Very simple. You just say 18 minus 6. Or you say 18 minus 6. 18 minus 6. I'm going to give you an example to try yourself, and I'm going to give you assignment to do. You submit to me. You give me the name and everything. Now, 18 minus 6. What will 18 minus 6 give us? 18 minus 6, it gave us 12. Thank you, 12. Don't forget, where did I get my 18? This is 18. Where did I get my 6? The first double bond we are using omega, this is, that's 12 minus 6. So you say 12, or you say 18 minus 6. 18 minus 6, that's 12. 12. I'm giving you a trick. I don't want us to, because this is the omega form of linoleic. If I want to write it in the delta form, it will warrant me to draw this guy according to omega. Then I'll now count. But I don't want to do that. I just want to transform it without drawing. So, everybody, let's work together. So 18 2. Now 18 minus 6 gave us 12. So you come here, the last position, you just come here and say this is 12. Give it to the last position, 12. That just follow the trick, is a trick. So 18 6 gave us 12. That's it. So this is your 12. If you don't understand, you can always listen to it. 18 minus 6, this is 18, this is 6. Give us 12. Now don't forget, how many double bond do we have here? We have 2 double bond. We have already looked at one is in position number 12, which I say it should be your last position for delta, your last position. So what then, if this is the last position, and the other one is 2, one is 12. So what is the first position here? What's the first position here? I told you that they are what's gap to each other. They are 3, 3, 3, 3 to each other. Do you get? So if this space is 12, then, and it's the last one, the last, then if this is 12, the next is what? The first one section was 9. So 9, 12. So see, I've been able to transfer this information straight to this information without drawing it. I think that is clear. So what is the point to note here? Don't worry, the video is long, but it's because of your exam. I want you to ensure you get every question related to this. Your crash class is coming. Ensure that you don't miss any part of the crash class. As we are preparing for exam, my OAU student, and for every other student that are about to write the exam, ensure to pay much attention to this. Now, what have we learned here? We've learned that we have omega and we have delta. Omega is for nutritionists, delta is for chemists. And I said we have 2 essential fatty acids. Fatty acid we get from diets, from food, is what we call essential fatty acid. It can be omega 3, it can be omega 6. I said, why do we call them omega 3, omega 6? Omega 6 means when you're counting from the back, the first double bond is in position number 6. Omega 3 means if you are counting from the back, the first one will be in position number what? 3. I think that is clear. Then I also explained to you that there's a way we can change this information straight to delta form. Now I'm going to do 1 now together, then I'll give you assignment. I think that is clear. Thank you. So I want to do 1 with us. I'm going to bring all this. So you can also try it before I try it. Who is that? I want to try alpha. Another guy, another common. Then you should know, probably I'll give you a list of some fatty acids to try. Alpha, I think you have alpha linolenic acid. Alpha linolenic acid. That guy is 18. And I want you to give me the information yourself. It's 18 3 n minus 3. Now I told you already, when you see this n minus 3 18, this is still the same thing as omega system. You wrote it according to what? Omega what? System. This is omega system. Omega system. Now, what's the meaning of this? I told you that this is 18 carbon with how many double bonds? That's 3 double bonds at 3 different positions. Now, when I call this 3, I think I told you, n minus 3, this 3 that is here will now be your what? It is omega 3, but I can write it for you in what you like. So this is 18 3. This is still omega. Omega. What's it? 3. This guy is an omega 3. Alpha linolenic acid is an omega 3 fatty acid. Without making a mistake, yes. Omega 3 fatty acid. But I think that I can write this like this and it's okay. But don't forget that how many double bond is there? 3. But I've already showed the position that the first position is the first position of our double bond. If they are counting it from the back, one of them is in position number what? 3. So it's an omega 3. But they can write like this. But to complete it, I told you, how many double bonds do we have? We have 3 double bonds. And I said all double bonds are always what? 3 carbons away from each other. So I'm to indicate all the positions. So if this is 3, If first one is in 3, the second one will be in what? 6, and next one will be in what? 9. So 18 carbon. After you make, you have 18 carbon, 3 double bonds. One is in position number 3, the other one is in position number 6, and the last one is in position number what? 9. This is what? An omega 3 fatty acid. How do I know it's omega 3? If we start counting from the back, the first double bond is in position number what? 3. This is an omega 3 fatty acid, essential fatty acid. Thank you. Now, this information I have here, I can translate it straight to what? To the delta form. I can translate it straight to the delta form. Do you remember what I taught you? Yeah. You come back here and say, this is according to who? According to nutrition. According to chemistry, you say 18, 3. Are you with me? Instead of using omega, what do we use? Delta. Now, how do I translate this information straight to the delta form? Very simple. Very, very simple. So what do you do? What's our trick? I taught you the trick. What's the trick? The trick is what number of carbon here is 18. 18 minus, who remember minus what? Minus the position of your first double bond. Where is my first double bond, everybody? 18 minus, where is my first double bond? Oh, yeah. According to omega, this is 18. You can just say 18 minus 3. Or if you write it this way, 18 minus 3. This 3 that is it. Or you say 18 minus the first position of the double bond. That's minus 3. What will 18 minus 3 give us? It will give us 15. And I said 15 will be your last position. You remember? Last. Then you come here, it's a trick. You come here and say 15. Last position. Now, meaning that we have 3 double bond, and the last position of the double bond is in position of what? 15. Abi? Then, how many double bond are we to have here? 3. If the last one is 15, the next year should be what? 15. Then you say, I told you that they are always what to each other? They are always 3 to each other. I think that is clear. 3 to each other. So this one is going to be what? 12. Then the next one is going to be what? 9. So we have, if you subtract 3 from 15, it gives us 12. If you subtract 3 from 12, it gives us 9. Very simple. Now, if you want to trust that this guy is still the same thing as this guy, we can draw the structure. Now, we are now going to draw the structure together. Everybody, pay attention. So, on the mind is 18 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'm trying to manage our board. Is that okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let me make it a little bit. Pay attention. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now I want to confirm that this will give me this. Right? This should give me this. That's what I want to confirm. Are we ready? Yeah, let's go. Now, according to this drawing, what do you see? You said there's 3 double bonds. This is omega. If I'm following omega, where am I counting from? From the front or from the back? From the back. So according to this guy, from the back, yeah, let's go. The first double bond is in position number 3. 1, 2, 3. There's a double bond there. 3. Next one is in position number 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's 6. Are you with me? 1, 2, 3. See, 1 is in 3, 1 is in 6, and 1 is in 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I drew this thing according to this omega. Abi? Now, and where did I count from? I counted from the back and I put the double bond. This same thing now that I counted from the back from 3, 6, 9. I want to confirm if it will give me 9, 12, 15. Is that okay? 9, 12, 15. Now let's go. 3, 6, 9. I want to confirm it will give me 9, 12, 15. I've drawn this thing according to 3, 6, 9. I counted from the back. Omega. Now delta, where do we count our delta? I want to give delta number. Where do we count from? Let us go. That will be 18. That will be 18 carbon. 3, Abi, let's go. Delta, I want to confirm this is this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Can you see? 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Can you see that I gave me 9? That's 1, 2, 3, 4, 5. From here, 1, 2, 3, 4, 7, 8, 9. 9, 10, 11, 12, 13, 14, 15. So you can confirm that while drawing it following P6, he gave me this. When I count it back, he gave me 9, 12, 15. I think that is clear. Meaning that this and this, they are the same. It's just that this is omega, this is delta. You count this from the back, it's 3, 6, 9. If you count it from the front, it will give you 9, 12, 15. Count it from the back, 3, 6, 9. Count it from the front here, 9, 12, 15. And the two of them will give the same type of structure. I think that is clear. Very, very clear. So, what type of omega is this? If somebody like this, you should have known that this is 3 or 3 is omega 3. I told you how way to know omega 3, omega 6. The first double bond, 1, 2, 3. Omega 3. So omega counts from the back. Omega counts from the back. Delta counts from the front. Is that okay? And the two shorthand method. When you draw the structure according to this, the structure should not be different from the structure this week here. Is that clear? Thank you. Now let's give this guy a name. I think we should give this guy a name and I'll give you some assignments. Let's give it a name. Yeah, let's go. Let's assume I'm counting from there. Yeah. That's 18. 1, 2, 3, 4, 5, 6, 7. It's 18. 18 is what? Octa, deca. Now you want to follow this delta now. See 9, 12, 15. Try enoic acid. In is telling us about the position of the double bond. Now, all you can say octa, deca, 3, 6, 9, trienoic acid. The two of them is the same. The only thing is that this is according to delta, this is according to omega. I think that is all. And I will give you some questions to try yourself. Answer to this in the comment section. Thank you. I want you to like this post, ensure you comment, and if you want more videos like this, ensure you encourage FarmJoe.